Great. Welcome to our Smart Caps lessons. We are having our math session once again, and I would want to welcome you back. I trust that you had a wonderful time starting your calculus and to know what you can apply calculus in different scenarios. Just to remind you, our lessons are fully interactive online, and you can reach us on the platform. And these lessons are proudly sponsored by VT Africa Holdings, the Basic Education Department, and other well-wishers. We would want to invite you into our assessments that will be taking place within the lesson. Be interactive with us and touch base with us and have your feedback, and we analyze what help you need. So you can reach us on www.hellosmart.com, and you can sign up as a guest and use the ID number 598751, and you have to add your name to that so that you can join in the assessment and actually show us how smart you are. So it's a very simple process that you can actually do, and you will be in the assessment. However, if you don't have a device, you can also have your pen and paper, your calculator, and be ready to work with us in mathematics. Today, as I said, we are continuing with our topic of calculus, and today we are looking at the rules of differentiation under this grand topic of differential calculus. And I was saying yesterday that the topic itself is very learned, and that's one of the key topics that set aside grade 12 from any other grade in your study of maths. So you will see that calculus is very applicable in many spheres of life. You can use it in science world, your engineering and all that, your mechanics. You also use calculus in your finance a lot. And nowadays you realize that it's applicable in different, many other fields. So today, in that way, we will remind you that yesterday we managed to use the differentiation by first, from first principles, and we were showing how you can use the first principles to differentiate expressions that will be posed to you in your exam. And these expressions or these questions will require you to use the formula provided and to be able to see parts of it and put it together into a final result. But today we want to look into another smart way to get our derivative, and we'll also have to start by deriving the derivative of a constant, then of a power function, then the derivative of a product of a constant and a power function. We'll also have the derivative of multiple power functions. All this coming with our interactive formal assessment that will be formative, and it will also tie together any loose ends we might have in approaching our calculus. So feel free to be joining in those formative assessments. Now, to get started, we are going to look at what I had called rule 1, which is deriving a constant. So when you are deriving a constant, you are having a function such as f of x equals to c, and then in that regard, you want to differentiate. So differentiation is always you are simply differentiating with respect to x. So if x is your independent variable, we are actually differentiating with respect to x. So whenever you have a constant such as this, your differential will be 0. In other words, you don't have any x to differentiate. Remember that. So you are saying that there is no differentiation possible here because we are talking differentiating with respect to x. And if you can visualize in terms of a graph scenario, you see that f equals to c can be something like f of x equals to 3, for example. This means y equals to 3. So y equals to 3 is this point, and it's actually a line that's horizontal. And yesterday, if you remember, I showed you that if something is going up, it's positive. If it's just horizontal, it's 0. If it's going down, it's negative. So this particular situation where we have a horizontal, the gradient here, grad or m is equals to 0, which we said gradient function is represented the same. It is the same thing as your differentiation. So your first differential is also your gradient function. Okay. So here is a situation where we have a y that is given. What will be our differentiation? So already you should be able to tell without any serious calculation. You should be able to tell what that would give you. Yes, so it gives you 0 for your f of x prime because this is a constant. There is no x on this constant 2, 3, 2, 7. So you simply differentiate it and it gives you 0 because the gradient will be 0. Look at our first formative assessment. We would want you to join in and interact with this one. And remember, to join in, you need to go to HelloSmart, you sign up as a guest, and then you put the ID number 598751. Lastly, you just put your name and you are in the mix. So we would benefit a lot if we are going to be interacting with the material that we are giving. You will remember that maths is not more of looking at it. It's very much more to do with it. Okay. So there you still have your number, that is 598751. Okay, so what is the first derivative of minus 17? I'm sure by now you have already checked it because it's just a click away or a moment away to realize that this is a constant. And so our answer would be D. So that would give us the first derivative of f of x. How about number 2? What is the first derivative of hint would be that don't be scared by the big number or the decimal. It will be very simple. So let's do that one as well. Okay, I believe that you have already figured it out in that sense that this is a constant. There is no x here. So your solution will be C, because in this case, this is a horizontal line like that. And a horizontal line would simply no gradient. So it will be 0 for the gradient. Okay. Let's another cut of this. So we want to start to look at the second aspect, which is the rule number 2. Rule number 2, we want to look at the derivative of a power function. So a power function is a function such that your x is an exponent. So if you are dealing with t, it's still the same application. X is just a name. So if you are dealing with m or q or whatever, or z, it's still the same applies. But we are usually using x. So that exponent on x is what makes it a power function. And to derive that, we have a very beautiful formula that you can use to actually discover what is the first derivative. So if you have a function such as your first derivative would be that. So you simply pull down the n, because you are having f of x equals to x n. So what you do, you pull down the n, and then you are going to have n x n. So this is happening in your mind. And then the next thing happens is that you now subtract 1 your original n or the exponent. So you finally have your formula like that. So this formula is very useful. In just 2 seconds, you can solve a very ugly looking expression and find the first derivative in no time. So it's a very useful and practical way to differentiate. Okay, so there we go. We have x to the 7th order. We want to determine the first derivative. So look at the working here. Very simple way to do it. That was our expression. And so when we derive it, you can see that we simply used our formula, which was that we pull down the 7, and then after pulling down the 7, we now subtract 1 from the exponent. So that would leave us with that 7x to the 6th power. So that will be 7x to the exponent 6, which will be your final answer. Let's check yet again another scenario. Let's increase the power. So in other words, if we are driving or in a space shuttle, we are pushing the pedal down, we are putting more power. So if the power increases, it becomes x to the exponent 17. You can imagine that's a big power there, but you see how simple you can get to your first derivative. The very same applies. You are simply going to use the same formula here, which is your f of x prime equals to n x n minus 1. So with that, you simply pull down your n, which is the exponent, which is 17 in this case. So 17, and then you subtract minus 1 from the original n. So your final answer would thus be 17x to the exponent 16. That's beautiful. So here is your chance to actually also find out what is the first derivative of f of x, where x is raised to the exponent 4. So what you can find in a few seconds, you should be fine with all that. So check how you can find the first derivative in just a few seconds. So that is great. I'm sure that you found out that f of x prime would give you, we put down the 4, then you are left with x, and we subtract the 1 from the 4, which gives us 3. So the exponent is always 1 less if you are using this formula. So if it was 4 as the exponent, it becomes 3 on top. But that original exponent, we pull it down as a coefficient in this case. So there is your solution. Let's proceed as well to check what would be the first derivative of this scenario. So check, and you are not perturbed by the negative exponent. The same rules apply. So apply your mind to it and you get your degree. Let's do it. Okay. I'm sure that you have managed to start to do all this. Those who might be slightly confused, maybe I used to also having y equals to x minus 5. So we might point it out right there that you could also find dy dx. So this is the same as f prime of x. It's the same thing because our function is actually f of x can be represented by y, the dependent variable. So your solution for all these, whether it's f prime of x or dy dx, you can also even have what we call the differentiation with respect to x. So it can also be represented like that. So all these things, according to the question at hand, will give you minus 5 that we pull down from the top, then x, and we subtract minus 1. So we subtract 1 from the minus 5, we get minus 6. So that would be your solution at D. That would be your D. So at this stage, we want to now look at our third. And this case, we are now looking at the derivative of a product, and actually we have a product of a constant and the power function. So we have kind of two things married together in the form of having it like this. So C is representing any constant, any number, and then N is an exponent. So to differentiate, you use this formula. You see that there is nothing has changed in terms of what you are doing. You are just being told to leave the C there where it was. So C is not affected. It must remain where it is while you do the differentiation you have been doing. Okay, look at a few examples that I've put for you. You're asked to differentiate minus 4x to the exponent minus what would be your first derivative. So you are going to leave the minus 4 where it is, but you then pull down your minus 7 and it comes here on the coefficient position, and then you simply subtract 1 from your exponent. So in this way, you would have much. So this is where the whole thing is being done, and you get 20x to the exponent minus 8, because you're going to multiply minus 7 times minus 4 to get 28. Okay. How about situation? Find first derivative of x if you are given that f of x equals to 3x squared. So you can join in and actually work out that will be A, B, C, or D. So let's see how you can do that. Okay, you will be impressed that this formula, the rule, makes it very possible not to waste any time on a question in just one work. You can easily find the derivative. So your derivative, in this case, you were looking at that expression. What will be your derivative there? So your derivative would be, I trust that you checked it out, that in this case you need to pull down the 2, but we also have our 3 that was there all along, and then 2 minus 1. So simplifying this would give us that. So this would give us 6x, which is on D. So I trust that you got the understanding of this part, but let's try yet another situation. So try this. Let's find out what you can come up with. All right, I think that's about time to have checked out how things are going. So let's work out how you did your solution. From the expression that is given of f of x on top, we realize that we can actually pull down the -2 as we've been doing, but there's also a -10 that was already a coefficient. We don't touch that one, we leave it there, and then x minus 2 minus 1. So we are always subtracting from the exponent. So these two coefficients multiplying will give us a positive 20, and then we have a -3 for the exponent. So your answer in this case was actually B. So I trust that you managed to get to all that in a short moment like that. So it's a beautiful method to solve a gigantic problem by simply finding the first derivative in this way. Let's see what else can happen if you have a derivative of a function with multiple power functions. So you're not just having one function with the power, but different ones. So that will be a bit of an interesting scenario where you have that for your function. So nothing changes much here. You are simply going to individually differentiate the same things that we are doing, and if they are adding or subtracting, you simply do the same thing with whatever is happening. So if it's minus, you still minus it. If it's going to be subtracting or adding, you still have the same, but you are differentiating each individual function. So let's look at an example so that we put this into real life. So if you have an expression with two power functions like 6x cubed plus 5x to the exponent minus the first derivative in this case would be, so that is our situation. The first derivative would be that we have to pull down the 3, and when you do that, we will get our two coefficients multiplying in the end, and then we have already subtracted on the exponents the -1. So look at it carefully. You will see that individually we are still doing the same thing that we've been doing. Like this is what we've been doing on an individual function, and this is what you've been doing. You are simply adding in between them or subtracting according to the sign that is given. So here is another scenario where you have different powers like that, but the same rule applies. We simply pull down the 6 to be an exponent, and then we also pull down the -3 from the exponent, and you see that on that exponent we are subtracting 1, and we simply find the simplification of that. So that will give us our final result. So nothing has changed except that we are dealing with two power functions in one expression. So there you go. Find the first derivative of 30x, that is minus 30x to the exponent -3 plus 20x to the exponent 4 negative. You are going to check what you can do with that. And you will remember that we have already shown you how you can look at these kind of individually, though in between you are adding them. So nothing has changed. So I'll give you a minute on it to working out and give us your feedback. Okay, that saves us well that I've given you a minute there to look at the first derivative of this. So let's check if your solution was correct. So in this case, you will pull down the 3, which is on the exponent, but you still remain with your 30. That was on the first expression. Then you have x minus 3 minus 1 plus. So the plus is in between. Then on the second expression, you are going to pull down the minus 4. And then you still have your 20. And then your x is going to lose out 1 degree of its power to become minus 4 minus 1. Okay. So this is one solution. So what would it give you? So this would give you minus 3 times minus 30 would give you positive 9, and then you have an x to the negative 4 plus minus 4 times 20 would be a minus. So I can actually change to be minus on this. So it will be minus 80, which would be x to the negative 5. So this is actually the second expression, which has to do with the of 20 to the exponent minus 4. Okay, so this, according to our answers provided, is the solution at, that should be solution number A. Let's check our answer there. A as we have shown. So that will be correctly our A. Let's look at the last few situations again of what we have set out to do. And in this case, we do have the first derivative of x if f of x is given like that. So let's have a few seconds to find out what will be the first derivative. Same rules apply. Nothing has changed. You are simply doing what we've been doing. So let's check out number 8, and let's have your feedbacks. Okay. Let's go into it. So I want to intentionally check the name of our function to y, which we have discussed, that sometimes a question comes having y where there is f of x. Nothing different at all. Is the same way of naming the function as y. So that would be representing the same expression that we are dealing with on the top. Okay. So with that in mind, I'm looking for the first derivative, which is dy dx. So that will be pulling down the negative. Then you have the 25 remaining. Then x to the -1, plus you pull down the -3, the 2 remains, and then if I may go to this side, you have x -3, -1. So this would give you -25 x -2, and then -6 x -4. All right. So if we didn't miss some negatives there, this should be our correct answer. You might need to look at it again to be sure. So this will be your dy dx, and the same dy dx is also your first derivative, or f prime of x. So what is our solution? What option was it? Number C. So yes, number C, as shown, would be. I would want to end by giving you an exercise where you are going to be having a game. Remember, we do have gamification as part of our where we want you to, in a playful, interactive way, and gain insight into how, through learning, you can also interact with games and learn things. So on your devices, you should actually be able to access this if you are logged on to our, and what you are going to do, you're simply going to start how many of you are racing, and then that would actually show you how you can do your differentiation and actually come up with the best result in all this. So get into it, practice, start choosing what you can do. So if you are just alone, you choose one. If you are two of you, you can also choose two for the same result. Okay. Yes, we could actually play. So with my partner here, we are going to play to show you how you can actually do it in your pairs. So we choose two because we are two of us, and my color is purple. Freddy's color is. So we'll give it a moment while it's loading. Okay, so here we are racing. I can even try to put a bit of power there. Yeah. So the first question comes. The first derivative of a graph gives the gradient of the tangent, true or false, A or B. So I'll just go with any one of those. So let's see what will happen. Oh, we all chose A. Fine. Second question is coming through. So A was correct. The first derivative of a graph is also the tangent. The average gradient of a graph between 2 points is equal to the gradient of the tangent. So is this going to be true or false? So our choice, I will just go to illustrate to you. The answer is actually coming up as A. So it is false that the average gradient will be equal to for a graph, there is a curve, so you are dealing with a tangent. First derivative of that is x that. So I'll go for A. I don't know what Freddy chose. Okay. So our answer is A, which is true. as we worked out. Then we are almost going to the final leg. What is the first derivative of a graph such as this? So it will be x cubed, and I'll take a in this case. Okay, so at least Freddy got it correct. It's actually not x, 8x. Okay, the first derivative of that is 12x, so I'll go for so for B. Well, Freddy has chosen A. Okay. Oh, Freddy got it, so he's getting the gist of the matter by now. And the game finishes with the score showing, which we can actually view and see that I got 3 correct, and Freddy also got 3 correct, and he got slightly more my result. So this was a good illustration of how you can actually play and also see your answers according to the derivative topic we're doing. With that, we would want to thank you for being with us. Join us tomorrow again at 10 o'clock as we will be doing the last aspect of calculus. Thank you very much.